So section 4.3, increasing, decreasing, and first derivative test. So here's the original two definition about how to find the increasing and decreasing. A function is an increasing on an open interval for any two numbers. You're going to pick any two numbers from the x coordinate in the interval if x1 less than x2 and the y of the y1 less than y2, that means the function is increasing. Or we never use this one. We never use the rule about the slope. The slope, if it's positive, we're going to take 2 points, plug in these 2 points in our function to get the y coordinate, and then we're going to find the slope. If the slope, the result of the slope is positive, that's increasing. The same thing here. We're going to do the same thing. If the slope, the result of the slope is negative, that means it's decreasing. This is the general definition about finding the increasing and decreasing, but we have to use the first derivative. So we already know the derivative for any function is the slope. The derivative for any function is the slope. So in this case, we need to check our derivative. So we're going to find the derivative for the function, and then we're going to do a test to find the function if it's increasing or decreasing. Let's try with an example. And we can use the same process when we start the next section. Let's start with this example. Remember, our goal is to find or to do the first derivative test. We're going to find the slope because the first derivative is the same thing as the slope. So let's check with this example. We don't have an interval. So first of all, and define an open interval on which the function is, there's our function increasing or decreasing. So let's start with the first thing, find the derivative. That means we're going to find the critical numbers. So here's my function, f of x equal x squared minus 4x minus 60. Here's my function. I'm going to find the derivative. That means I'm going to find the critical numbers. That means f prime to the x equal the derivative of x squared is going to be 2x. The derivative for negative 4x is going to be negative 4. How are we going to find the critical numbers? We're going to take the derivative equal to the 0. That means 2x minus 4 equals 0. It's linear equations. I'm going to solve this one. Move the constant here onto the other side. And add 4. That means 2x equal 4. Divide by 2. So x is going to be equal to. So here's the critical number. Now, next step, which is called the first derivative test. I need to test the first derivative. Let's do a simple graph here. There is the critical number. Because my goal is to find the interval in which the function increase or decrease. So I'm going to start, here's the x coordinate, negative infinity here, and here is infinity. That's me. I need to test my function here on this side from negative infinity to the critical number. It's increasing or decreasing. That's why I'm going to use the first derivative test, which is you're going to choose any number on this side. You choose any number here. Easiest one, less than 0, I'm going to choose the 0. Less than 2, I'm going to choose the 0. Then I'm going to choose any number here between 2 and infinity. Let's choose the 3. Let's do the first derivative test. That's me. F prime to the 0 is going to be equal. Therefore, we're going to plug in here because we need to check the derivative. So I'm going to plug in 0. Here's my derivative. It's going to be 2 times 0 minus 4. 2 times 0 is going to be 0. That means f prime to the 0 is going to be equal to negative 4. So from negative infinity to the 2, the function is decreasing. Because our -4, that means the function is going down. When you graph it, you're going to see the function from negative infinity to the critical number 2 is going down. Let's check the other one, which is a 3. That means f prime to the 3 is going to be equal. And then the 3 here. So it should be 2 times 3 minus 4. It's going to be 6 minus 4, and the result is going to be 2. That means from 2 to the infinity, the function is increasing. So that's our goal, to find the interval. So from negative infinity to the 2, the function is decreasing. And from 2 to infinity, the function is increasing. That's why it's called the first derivative test. We're testing the slope on this side, and we're testing the slope here. We find out the slope is going down because it's negative, and the slope is going up because it's positive.
Thank you. Thank you.
So that's why it's called the first derivative test. Okay, this is, we have an easy function here. What about if you have e to the x, sine, cosine? So the important thing here is how to find the derivative. You're gonna go back and use the 7 derivative rules. What about if you have quotient? You're gonna go back and use the quotient as a step. You see the steps here is one step. If you do any mistakes about finding the derivative, everything is going to be wrong. Okay, so the derivative is just the steps. So for this example, they ask you to identify the open interval on which the function f of x equal x squared minus 10x increasing or decreasing. So we're going to do the same process. So here is my function f of x equal x squared minus 10x, and then I'm going to find the derivative. The derivative of x is going to be 2x minus 10. So our goal, the first thing, to find the critical number. The critical number, which is mean the function is going to change from increasing to decreasing, from decreasing to increasing. This is called the critical number. Like the previous example, the critical number is 2. Now let's check. How are we going to find the critical number? We're going to check the derivative and equal to 0. Let's solve this one. We're going to add 10. That means 2x is going to be equal to 10. Divide by 2. So x is going to be equal to 5. So here is our critical number. So based on this critical number, we can find, here is our line. The critical number is 5. Always there is infinity. There is the infinity. So let's check our interval, which is by using the first derivative. My first derivative, f prime to the x, is going to be equal to x minus 10. But we have to be careful. We need to find the first derivative test. That means the first derivative, not the original function equations in function. So now I'm going to choose any number less than 0, less than 5. And always check here. You can choose any number, but always I'm choosing 0 less than 5 because 0, it's easier to plug in here. So I can choose 0 here. And here you can choose 6. Doesn't matter. 6, 7, 8, 100. Now f prime to the 0 is going to be 2 times 0 minus 10. This is 0. That's equal to negative 10. So our function here is going to be negative, so it's going to be decreasing. Now f prime to the 6 is going to be 2 times 6 minus 10. And in this case, going to be 12 minus 10, and it's going to be 2. That's mean positive. So from 5 to infinity, the function is going to be Increasing because it's positive number. So write down the interval from negative infinity to the 5. The critical number is going to be decreasing. And from 5 to infinity is infinity. Now, if you look to the function here, so this is simple graph. Decreasing and decreasing. So at this point, we have relative minimum. Because it is decreasing and increasing. So it's a relative minimum. Now, how are we gonna find the relative minimum? If they ask you, find the relative minimum point. So I already know my critical number x equal 5. I need to find the point, which is the function is going to be the minimum point, the lowest point. I have the x, how am I gonna find the y?
Plug into the equation.
Plug into the equation, plug in here, not the derivative. Plug in the function to find the y coordinate. That's mean we're gonna plug in, here is my function, f of it, let's do it f of 5. F of 5 is going to be equal 5 squared minus 10 times 5 equal to 25 minus 50, and then it's going to be negative 25. That means this point is the lowest point, the minimum point, the relative minimum, which is equal 5 negative 25 is relative minimum. Okay, that's how we're gonna find, because they're gonna ask you find the relative minimum, relative maximum. So you have to find the point, not just the x coordinate. That means you have to find the y. If you graph it now using the calculator, you will see the function have the minimum point at x equal 5. This is the lowest point on the whole graph, okay? So and define the open interval on which the function is function f of x equal negative 2x, negative 2x squared plus 8x plus 6, increasing, decreasing, and find relative max and minimum. So the first thing, I'm just gonna find the critical numbers. That means f of x equal negative 2x squared plus 8x plus 6. Find the derivative. And find to the x is going to be equal. Find the derivative for the first term is going to be negative 4x plus 8. Now find the critical number. I'm going to take the first derivative and equal it to the 0. Solve this one, it will be negative 4x equal negative 8. That means x is going to be equal negative 8 over negative 4, which is equal to 2. So here is the critical number. So my critical number is x equal 2. But here is the graph. Here's 2. I already know this is negative infinity, and this is positive infinity. Next step, we need to check the interval. That means here is my derivative equal negative 4x plus 8. Now choose any number here, less than 0, less than 2. I can choose 0, negative 1. Which number I'm going to choose? It's up to you. Again, choose any number. Here is the easiest one. I'm going to choose 0. And here I can choose 3. So f5 to the 0 is going to be negative 4 times 0 plus 8. That's mean, which is equal 8. Positive number, that's mean a function here is increasing. Now let's check the 3. F prime to the 3 is going to be equal -4 times 3 plus 8. And it's going to be -12 plus 8 is going to be -4. That's me. Here is decreasing. So to write down the interval is going to be from -infinity to the critical number 2, the function is increasing. From 2 to the infinity, the function is decreasing. So here's our interval. Now we need to find the relative max or minimum. Check the point here at this point too. The function going up and then going down. So this is max. Max. Be careful, sometimes you can have 2 critical numbers. So you have maximum and minimum. But with this example, we have only 1 point, 1 critical number. That means 1 maximum or 1 minimum. Going up, going down, so it's going to be a relative max. We need to find the point. So x equal 2, that means f to the 2 is going to be equal. Like in here with our original function, find the y coordinate. So it's going to be -2 times 2 squared plus 8 times 2 plus 6. -2 times 4, -2 times 4, here is -8 plus 16 plus 6. So the result is going to be 14. So here we're going to be -2, 15 minus 2 is going to be 14. That means the point is going to be 2 and 14 is relative. Okay, that's it. We have only 1 point because we have only 1 critical number. So here's another example and then open interval in which the function is increasing and decreasing, and find the relative minimum, maximum, and minimum. So here is my function, which is f of x equal 3x cubed plus 18 x squared minus 45x. Find the derivative. It's going to be 9x squared plus 36 x minus 45. Yes or no? Now, the first step, we're going to find the critical number. So I'm going to take the derivative and equal to 0. It'll give me 9x squared plus 36x minus 45 equals 0. I can take the 9 as a common. The left is going to be x squared plus 4x minus equals 0. Now this is easier to factor. So here is the 9, open 2 parentheses, x, 5, 1, and I need positive, so I'm going to put positive here and negative here. So now we need to solve this one. Find the critical numbers. 9 equals 0. This is the wrong statement. X plus 5 equals 0. That means x equals -5. This is the first critical number. And x minus 1 equals 0. That means x equals 1. This is the second critical number. So we have 2 critical numbers. So be careful. When you write down the critical numbers on the line, this is the positive infinity, and here is negative infinity. 2 critical numbers, always you have to write down the negative, the smallest one, because this is the x coordinate. So -5 here and 1 here. If you do the opposite thing, it's going to be wrong. So be careful from this one. So it's from the smallest number to the highest number. Now we need to find the intervals. I'm going to go back and check the derivative. F prime to the x equal 9x squared plus 36x minus 45. I'm going to choose numbers. -5, I'm going to choose -6. Between -5 and 1, I'm going to choose the 0. Between 1 and infinity, I can choose 2. And again, you can choose any number, it's going to be the same result. Because your goal is to find just the increasing and decreasing. We're not going to choose the result when you test the derivative. So first thing, f prime to the -6 equal 9 times -6 squared plus 36 times -6 minus 45. Tell me how much is going to be the result. Will it be positive or negative? It's going to be, this is 36, 72, -72, -45. 36 positive times 9 is going to be a really big number, it's going to be a positive number. Times the -6 is going to be equal
216.
63,
216.
216, 216 only for this one.
Oh, no.
Yeah, minus 72 minus 45 is going to be 63. I'm not sure, check.
No.
Yes, sir. I'll check it.
Good. So now we're gonna check the second one. So this is positive, and again, I'm here up only about the sign. It's positive, that means this is increasing. Now let's check the 0. F prime to the 0 is going to be 9 times 0 squared plus 36 times 0 minus 45. This is 0, this is 0. That means f prime to the 0 is going to be -45. So in this case, this one decreases. So you can tell, you see, you can tell here, this is a relative max. Increasing, decreasing. It's a relative max. Let's check the second critical number. Like the second interval here, when f the prime is 2. F prime to the 2 equal 9 times 2 squared plus 36 times 2 minus 45. So you see, this is 72. This one is going to be -45, is going to be positive number. This is also positive. So the result is going to be positive. How much the result for this one? F prime to the 2 is going to be equal
63 as well.
63 as well. Okay. Sure, 63 as well. Yeah. Anyway, it's a positive number. That means this one is going to be increasing. So now we have the intervals, which is from -infinity to the -5 increasing. And from 1 to infinity is increasing. See, from -infinity to the critical number -5, and from 1 to infinity is increasing. And we have from -5 to the 1 is now you can tell from this simple graph You can tell this is a max and this is a minimum. Max, minimum, but here is -5. One, we need to find the point. When they ask you to find the maximum, relative max and relative minimum, you have to write down the point as an X and Y. You're not gonna just say -5 and 1. No, it's going to be wrong. They ask you, so we have -5. That's mean we need to find the Y coordinate. So when X equal -5, F to the -5, here is F. That's mean when you need to find the Y coordinate, you're gonna go back here. So you're gonna plug in -5 here. It's going to be 3 times -5 cubed plus 18 times -5 squared minus 4, 5. It's a maximum. This one is going to be how much is going to be?
Wouldn't we multiply the 45 by,
Oh, 5 by
Yeah.
-5. Perfect.
I got a 300.
Yes, because it's supposed to be positive. It's a maximum. So here's -5, and it's going to be 300. Here is the maximum, the relative max. Now, when X equal 1, we're gonna do the same thing. F to the 1 equal 3 times 1 cubed plus 18 times 1 minus 4, 5 times 1. How much is going to be that?
I got a -24.
-24. -24. That's mean 1 and -24 is relative minimum. That's it. So when they ask about relative max and relative minimum, I have to find the point with X and Y. Let's do the same thing. Find the open interval on which the function, now check our function, f of X equal 5 minus X and X plus 1 squared. You do exactly the same process, but the first step is to find the derivative or find the critical number. This is the important step. So here is my function, f of X. Going to be equal 5 minus X and X plus 1 squared. Now I need to find the derivative of this function. It's a product between two functions. So it's going to be the first one, 5 minus X times the derivative of the second one, which is 2 X plus 1, 2 minus 1 is going to be 1, times the derivative of inside, which is 1, because this is 0, plus the second one times the derivative of the first one. So here's the second one times the derivative of 5 minus X is going to be -1. And we need to put these together. So f of prime to the X is going to be equal 5 minus X. 2 times 1, you can distribute here. It's going to be 2X plus 2. And the plus -1 is going to be minus X plus 1 squared. See, this is only to find the derivative. Now, what are you going to do next? So I'm going to FOIL this side. So f prime to the X is going to be equal. Before, if you're not FOILing, let's do, I'm taking the common from these two terms. But then if I FOIL it, I need to go back and factor it to find the critical number. So it's already factored. I'm gonna take x plus 1 as a common. So I'm gonna say x plus 1 as a common. What's the left? The left on this side is 2, 5 minus x. Plus, the left here is negative. That means here is negative. And just x plus 1. So I'm going to do this step. Why? Because if you FOIL this one and combine the like terms, you're going to get polynomial. Maybe polynomial with quadratic, but in some cases it's going to be cube, which is going to be a little bit harder to factor it. It's already factored. Why I'm going to combine everything, then factor it again. I'm going to take the common between these two terms. Now this is easier to combine. 2 times 5 is going to be 10 minus 2x minus x minus 1. Then f prime to the x is going to be x plus 1. It's going to be negative 3x and plus 9. See, it's already factored. We don't have now to FOIL it. Let's keep it like this. Equal the derivative to the 0. That means f prime, which is going to be x plus 1 and negative 3x plus 9 equal to 0. Then x plus 1 equals 0. That means x equals negative 1. And the next one is going to be negative 3x plus 9 equals 0. That means x is going to be equal to 3. We have to solve this one. So we have 2 critical numbers. Negative infinity, and here is the infinity. And negative 1, 3. So I'm going to put the smallest number first, and here is 3. Next step is to choose the numbers. I'm going to say, okay, negative 1, I'm going to choose negative 2. Between negative 1 and 3, I can choose the 0. You can choose any number between negative 1 and 3. You can choose any number between 3 and infinity. Choose 4. You don't have to choose a really big number. So the first thing we need to check, where is my derivative? Here. You see, I'm going to use this one as a derivative. I'm not going to use this one, the simplest one. Now, the derivative f prime to the negative 2 is going to be equal negative 2 plus 1, and it's going to be negative 3 times negative 2 plus 9. How much the result? This is 15. 6 plus 9 going to be 15. 15 minus 1. No, here's because multiplication. So here is going to be 6, 15. 15 times negative 1 is negative 15. Be careful because you have to multiply the result from these two sides. That means this one is decreasing. Now f prime to the 0. So it's going to be 0 plus 1. And it's going to be negative 3 times 0 plus 9. This is going to be 1. And here's 0, 9. So 1 times 9 going to be 9. So this one is going to be increasing. F prime to the 4 is going to be 4 plus 1, and it's going to be negative 3 times 4 plus 9. How much is going to be negative 12 plus 9? Going to be negative 3. times 5, it's going to be also negative 15. That's the years. So in this case, from negative infinity to negative 1. From negative infinity to negative 1 is decreasing. And from 3 to infinity, it's also decreasing. And from 3 to infinity is decreasing. From negative 1 to 3 is increasing. Negative 1 to 3 is increasing. That's only the first part. Now, next step, you have to find the relative mass and relative minimum. Now tell me how much it's going to be. When x equal negative 1, you can tell at negative 1 is relative minimum. And at 3 is relative max. Go ahead. How much is going to be when x equal negative 1? How much the y? You're gonna go back and plug in the original fraction here. So 5 minus negative 1 is going to be 6, which you're gonna add. So that's a plug-in. That's mean f to the negative 1 is going to be 5 minus negative 1. And the next part is going to be negative 1 plus 1 squared. This is 0. 0 squared is going to be 0. 0 times any number, 0. That's mean the relative max, x is negative 1 and y is 0. It's the relative minimum. Relative minimum. When x equals 3, f to the 3 is going to be equal. You're gonna plug in here. So 5 minus 3. And the next part is going to be 3 plus 1. So it's going to be 2. And here is 4 squared. 4 squared is going to be 16. 16 times 2 is going to be 32. That means 3. 32 is 32.